Hello everyone, this is Mrs. Raposa, and I am making this video for those students who may have been absent on either May 25th or May 27th on the days that we took notes on 8.4 Part 1, Trigonometry Identities. We call them trig identities because we can rewrite a variable expression like 1 over tangent theta as cotangent theta, because tangent is the reciprocal of the cotangent. These reciprocal identities you already know. You already know these identities. You know that secant is the reciprocal of cosine and that cosecant is the reciprocal of sine. We talked on May 25th about relationships with negative angle measures. What we're concerned with here is finding out whether the sine of negative theta is exactly the same thing as sine of theta, or if it's the opposite of sine theta. So basically, we're trying to figure out if these angle measures will be the same or opposites. Theta, I don't know what the angle measure is. It could be 20 degrees, it could be 50 degrees, 170 degrees, we don't know. But the sine of negative theta will actually be the opposite of sine theta, because sine is y over r. And on the unit circle, where the radius is always 1, and we always start at the point 1, 0, if I move a negative rotation, I'm going clockwise, and I'll end up maybe down here somewhere. If I use a positive angle rotation, I would end up here. These 2 points on the unit circle have the same exact x-coordinate, but the y-coordinates are exact opposites of each other. So therefore, the sine of negative theta is the exact opposite of sine theta. So we say sine of negative theta is equal to negative sine theta. For instance, sine of negative 30 degrees is negative 1/2, negative 1 over 2. The sine of positive 30 degrees is positive 1/2. It would be y, which would be 1, over the radius, which would be 2 if we were not on a unit circle. So the sine of negative 30 degrees is negative 1/2, and the sine of positive 30 degrees is positive 1/2, so they're opposites. Since cosecant is the reciprocal of sine and depends on the y-coordinates also, then cosecant of negative theta would be the opposite of cosecant theta. Cosine value and secant values depend on x, the x-coordinates. And whether you use a negative rotation of theta or a positive rotation of theta, these 2 points on the unit circle will be these 2 points will have the exact same x-coordinates. So the x-coordinates, or the cosine values, will be the same. So we say that the cosine of negative theta is equal to cosine theta. For instance, the cosine of negative 60 degrees is 1/2, and that's also equal to the cosine of positive 60 degrees. That's also 1/2. Tangent is the y divided by the x, or the slope of the terminal ray, rise over run. Tangent of negative theta would be negative y over x. Tangent of positive theta would be positive y over x. So the tangent values would be exact opposites of each other. And since cotangent depends on y and x also, it's the reciprocal, since the tangents would be opposite, the cotangents would also be opposites. For the cofunction relationships, these were the notes that we took on May 27th. Everything that's in blue here, we did on May 25th. And we finished up this part on May 27th. So on May 27th, we talked about cofunction relationships, which really just is a relationship between the sine, cosine, and tangent of complementary angles. So basically, I want to compare like the sine of theta to the cosine sine of 30 degrees to the cosine of its complement, 60 degrees. Remember, complementary angles are 2 angle measures that add up to 90 degrees. So the complement of 30 degrees is 60 degrees. And I used this example. if I make a 30-degree reference angle in quadrant 1, then the y-coordinate is 1, the x-coordinate is √3, and the radius is 2. I'm sorry, this is not the unit circle, because on a unit circle the radius would be 1. So we've doubled the unit circle here to make it easier. If I put a 60-degree angle in quadrant 1, now the x and y coordinates have swapped, because now the 30-degree angle is here, is an opposite the 30-degree angle would be 1, and the opposite the 60-degree angle would be √3. So as you can see, the y and x coordinates swapped, which also means that sine and cosine swapped. So basically, the sine of 30 degrees is exactly the same thing as the cosine of 60 degrees. Sine of 30 degrees equals the cosine of 60 degrees, because cosine would be adjacent over hypotenuse, right? 90 minus 30 would give us 60 degrees. So this is one of the cofunction relationships, and it has everything to do with x and y swapping places, because the 30-degree angle and the 60-degree angle, the complementary angles here, they swap places on this 90-degree reference angle. Tangent, remember the tangent is y over x, so tangent of 30 degrees, that would be y over x, 1 over √3. Well, that's the same thing as the cotangent of 90 minus 30 degrees. 90 minus 30 is 60, so the cotangent of 60 degrees is x over y, 1 over √3, the same measure. And likewise, the cosine of theta is the sine, cosine of an angle measure is the sine of the complement of that angle measure. And the relationships will also work with secant and cosecant, because secant is r over x and cosecant is r over y. So the x and y swap places. So secant of 30 degrees, for instance, is 2 over √3, r over x. But that's the same thing as the cosecant of 60 degrees, which is r over y, 2 over √3. The Pythagorean relationships are ones that you've been using all along. You may recall that we were given some problems where you were told that maybe the sine of an angle measure was 5/7. Find the cosine, the secant, and tangent, and etc., all the other 5 trig ratios of that. So what you would do is, if the sine is 5/7, then sine is y over r, so this would be 5 and this would be 7, and then we'd have to use Pythagorean theorem, a squared plus b squared equals c squared. Well, on the unit circle, where the radius is equal to 1, if you rotate this point 1, 0, any amount of degrees or radians, the point on the unit circle will have coordinates cosine theta, sine theta, because cosine theta would be the x-coordinate and sine theta would be the y-coordinate. So we would know that a squared plus b squared equals c squared on this reference triangle in the first quadrant, or any quadrant really. So a squared plus b squared equals c squared means that this value, this length, which is the same as x, which is cosine theta, and this value y is sine theta, so cosine theta squared plus sine theta squared equals 1 squared, which is 1. So that's how we came up with this identity. Sine squared plus cosine squared equals 1. That means the sine value is being squared, not the angle measure. So we have to find, maybe for instance, the sine of 30 degrees is 1/2. So the sine squared of 30 degrees would be 1/2 squared, or 1/4. From this relationship, we can get 2 other relationships by doing some division. If I take all 3 terms in this equation, sine squared plus cosine squared equals 1, and divide the entire equation by sine squared theta, I end up with sine squared theta over sine squared theta, which is 1, plus cosine squared theta over sine squared theta. Cosine over sine is cotangent. So cosine squared over sine squared will be cotangent squared. And then I set that equal to 1 over sine squared. Remember, 1 over sine is just the cosecant. So 1 over sine squared will be cosecant squared. Likewise, if I take this trig identity here and divide everything by cosine squared, I'll get this relationship. Tangent squared plus 1 equals secant squared. On the flip side of these notes, we had some identities that come about just with some simple subtraction. For example, here's the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. If I subtract cosine squared theta from each side of this equation, I'm going to end up with just sine squared theta on one side, and the other side will be 1 minus cosine squared. So 1 minus the cosine squared of any angle measure is equal to sine squared of that same angle measure. 1 minus sine squared, to do that, all I need to do is subtract sine squared from both sides of these equations. So subtract sine squared from this side, and I'm left with cosine squared. And on this side, I would have 1 minus sine squared. So 1 minus the sine squared of theta is equal to the cosine squared of that angle theta. And from this relationship right here, all I have to do is subtract 1 from each side of this equation to get secant squared theta minus 1 on this side is equal to tangent squared. Over here, all I have to do is subtract tangent squared from each side of this equation, and I end up with secant squared minus tangent squared equals 1. And likewise, to get this identity, I subtract 1 from this identity that we got on the front side right here. Just subtract 1 from each side and you end up with this identity. And to get this identity, we just subtract cotangent squared from each side.